In this video, we're going to continue to work on writing the equation of a line. In particular, we're going to focus on writing the equation of the line when the information we're given is two ordered pairs. Now, in order to work on this, we first need to look at how to determine the slope given two ordered pairs. So to get into this, let's look at the graph of a line. And consider, if we already have the graph of the line, could we determine the slope of that line just by looking at its graph? Well, the way we used slope before is we would put a point on the graph, and then we could get from that point to another point on the line by counting off the slope. And so remember that a line is made up of infinitely many points. So I could really choose any point along this line and then count to another point along the line, and that would give me the slope. And that even includes the points that are not on grid line intersections. Any point along that line and to another point gives me the rate of change between those 2 points. The challenge is when you don't use grid lines, then you're having to count in fractions or decimals, and it's rather challenging. Alright, so what we're going to need to do is pick out points that are on grid lines. So I could start with this point. That goes through a grid line intersection, or down here. You kind of just guesstimate, and my line's not perfect. I know what I intended, so that's how I know what this is. When it's printed, it's a lot easier to tell, but those are kind of grid line intersections. And so we just need to figure out how many x's it would take and how many y's it would take to stair step from one of these to the other. And you notice they're all the same, and that's what causes it to be a line, because it's consistent. And so if you look at that, to get from one point to the other using that stair step, it's going to take 4 x's and 3 y's. And so with that, we can conclude that our slope, or m, equals 3/4. Remember, the x number is the number on bottom. The change in x's is on bottom, and the change in y's is on top. So we go over 4 x's, and we go up 3 y's to get from one point to the other. And we can determine our slope that way. Now, something that's interesting is if instead of doing that stair-step effect, remember I said it's any point, so I could go from this point to this point up here. If I did that, I would just be taking bigger steps, and then in this case it would be 8 x's for 6 y's. 6 over 8, because remember the change in y goes on top, equals 3/4. So it still reduces to the same equivalent fraction. So you really can do any point to any other point, and it's going to reduce to the same equivalent fraction. Now let's imagine that instead of being given the graph, what we were given were the ordered pairs. So this would be the ordered pair -8, -3, and this one up here would be the ordered pair 0, 3. So let's say we were just given those ordered pairs, and we needed to determine the slope from those ordered pairs. Now we could graph it, but we're going to get to ordered pairs that are decimals and stuff like that, so graphing it isn't going to help us figure it out any, really. But when I think about what I did on the graph, I essentially just counted how many x's I went over, and I counted how many y's I went up to get to that point. Well, we can do that using math without actually counting. To figure out the distance between 2 points, 2 locations, we subtract their numeric values. So over here, what I can do in order to figure out the distance between my x's is I can just subtract. I can take my -8 minus 0. That'll tell me how far apart they are. And I can figure out the distance between my y's by taking my -3 minus 3. Now when I do the math on that, I'm going to get a -6 over -8, which again reduces to my 3/4. So that works. And I do want to emphasize that you could do it in the other order. I could take the 0 minus the negative 8 for my x's and the 3 minus the negative 3 for my change in my y's. Now doing the math on that gives me an 8 for my x's and a 6 for my y's, which again reduces to 3/4. So it doesn't matter which x value you put first and which y value you put first. But what does matter, if you notice both times, I have an order pair of 0, 3. So if I list those values second, they both go second. If I list them first, they both go first. That's what matters, is if you put one of them first, its partner has to go first. With the order pair negative 8, negative 3, when they went first, they both went first. And when they went last, they both went last. That's the ordering that matters. You can put either one first, but once you decide to put it first in the numerator or denominator, its partner has to go first in the other location. So that's kind of the approach. For those of you that have seen this before, you've probably seen this called the slope formula. And that's m equals y2 minus y1 over x2 minus x1. You don't have to memorize that verbatim, but just understand that what it's saying is subtract the x's in the denominator, subtract the y's in the numerator. Or find the distance between the x's and put it in the denominator, find the distance between the y's and put it in the numerator. Reduce your fraction and you have your slope. So that's how we determine slope given 2 points. Now what we're going to do is turn to actually writing the equation of a line when we're given 2 points. Let's say we have this example. Write the equation of the line that passes through the points -2, and 3, 4. Now the reason, well, when we're writing the equation of the line, we're going to use our slope-intercept formula of the line. Y equals mx plus b. And the numbers that we're looking for to fill out what the equation of the line is are the m and the b. Now, sometimes they actually tell us the slope, which is nice. Sometimes they actually tell us the y-coordinate, which contains the b, which is nice. Sometimes they don't tell us any of that, such as in this example. So we need to determine the slope and we need to determine the y-intercept. So when they don't tell us any of what we need, we're going to first determine the slope. And then after that, it'll be like the previous stuff that we've worked on where we use the slope to determine the y-intercept. Or more specifically, we'll use the slope and an order pair to determine b, which is the y-coordinate of the y-intercept. So that's and then once we have the slope and the y-intercept, we put that into y equals mx plus b and we're done. So let's go ahead and work on determining the slope. To do this, we're going to use that slope formula that we just talked about. So we're going to take our x's on bottom and our y's on top. And so our y's are -2 and 4. So I'm going to take a 4 minus a -2, subtracting my y's. In the denominator, I'm going to take 3 minus a -2. And notice how if I have a negative number, I have the negative number, but I also have a minus because we are subtracting them to find the distance between them. Alright, so once I have that written out, I'm just doing that math there. Whenever you have the double minus, the minus a negative, that's really a positive, right? So that gives us 6 over 5, or 6/5. And that's our first step. Now our second step was to use our 6/5 to go find b. I'm going to erase this information but keep the 6/5 for the sake of space on the screen. So we're going to use our slope and we're going to plug that into our y equals mx plus b, and then we can use either order pair. We can use the -2, or the 3, 4, and we're going to plug those into the x and y. So I'm going to use the 3, 4. I was going to say -2, but I changed my mind on the fly. I'm going to use the 3, 4 and plug those into the equation and also the m. I'll plug a 6/5 in for. Alright, so when I do that, I get 4 equals 6/5 times 3 plus b. Now I want to make sure you know where all that's coming from. The 6/5 I plugged in for the m in the m slot. The 3 was the x coordinate of the order pair I chose, and I plugged that into the x in the equation. And the 4 was the y coordinate, and so I plugged that into the y for the equation. Once I get everything plugged in, I'm trying to determine b, so now I have an equation with only a b variable, which means I can solve for it. Have a little bit of fraction work to do here, but it's not too scary. Nothing reduces, so that's actually going to give me an 18/5 plus b. Now what I want to do is go ahead and subtract my 18/5 from both sides. And that's going to give me a b equal to 2/5. So that's the b we were looking for. First we found the slope, now we found the b. Now we need to actually just write the equation of the line. Again, don't mess up and stop with finding the b. Our mission is to write the equation, and b equal to -2, while that's an equation really, it's not the equation of the line. So putting that all together, we get that the equation is y equal to 6/5 x plus 2/5 for the b. And that's our final answer. Okay, I'm going to do another example where the points that they're giving us aren't as nice as far as the numbers go. Same process, I just want to emphasize why it is that we need to be able to use the slope formula in order to determine slope, instead of just relying on graphing. So here our order pairs are 3.2, 0.5 and -6.3, 1.7. So to write the equation of the line as it asks us to do, the first thing we need to do is to find the slope. And this is where we take and we subtract our y's on top and we subtract our x's on bottom. Subtracting the y's on top would be, and it doesn't matter which one goes first, a lot of people like to put the second one first out of habit, but we would do 1.7 minus 0.05, and then putting the x's on bottom, we'd do -6.3 minus 3.2. And again, it doesn't matter which one goes first, but what we need is for the same order pair pieces to be first. If they go in the order pair together, they should be first in the slope formula together. Okay, so doing the math on that, we get 1.2 divided by -9.5. And since these are already decimals, we'll go ahead and just divide this down to a single decimal. And when I do that, I get -0.13. I rounded that to 2 decimal places. Usually if this is going to involve decimals, the directions will tell us what to round to, so don't worry about that too much. Alright, so that's going to be our slope that we use as we go on. The next thing we want to do is find our b. To do that, we choose either one of our points and plug that into the equation, as well as the slope that we just found. I'm going to use this first point because the values seem nicer to me. So that's what I'll plug into the equation, along with my -0.13. That will give me 0.5 equal to -1.3 times 3.2 plus b. Now taking the -1.3 and multiplying it by 3.2, I get -0.416. And then what I'm going to do is add that to both sides in order to isolate the b. And that'll give me b equal to 0.916. Okay, so I've got my b, I found my slope, I found my b. The only thing left to do is to put it all together and write the equation. When we do that, we get y equal to -0.31x plus 0.916. And that's it. That's our equation with all the lovely decimals. So hopefully this process is looking good for you. Go ahead and try a few problems on your own and see how you end up.